For years, I found myself trying to teach students how to be able to estimate square roots. Now, they always struggled with it for one reason or another. For example, some students struggled with it because they didn't even understand what a square number was. And of course, how are they going to understand what this symbol is, of course, if they don't know what a square number is and how that relates back to it? So I came up with this model, and that is to be able to use this in order to estimate square roots. And in order to do that, it comes in 4 phases. So the first phase is, first of all, explaining what a square number is. For example, if I have 3 squared, well, I'd represent that using a 3 by 3 grid. And as we know, 3 times 3 will get us 9 dots. So we know 3 squared is equal to 9, and you can see here that the dots come together to make a square. Same with 4 squared. We can see I'm going to make it a 4 by 4. I'll come around and make sure I fill in all these dots. So a 4 by 4 array will give me 16 dots. So 4 squared is equal to 16. Now, the first phase, I let students just play with this for a little bit. I gave them a couple of questions, so 5 squared, 6 squared, just so they can get their head around what a square number actually is and why it's called a square number. That is because it actually makes a square. When students understand this, understanding square roots then becomes a lot easier, which brings me to phase 2 of the lesson. Now, phase 2 is introducing them to the square root symbol and actually helping them to understand what a square root actually means. For example, if I have the square root of 16, well, what that really means is I've got 16 dots here that form a square. What is my side length of that square? Now, as you can see, if I've made a square with 16 dots, my side length will in fact equal 4. And that's really quite straightforward and quite easy because they see, all right, my square is made up of 16 dots, my side length is 4. You can actually see what square root actually means. Once again, I get students to play around with this for perfect squares. So I might get them to do 16, 36, 25, all of those types of perfect square numbers so that they can then go through and see how square root relates to square numbers. Then it's time for phase 3 of the lesson. Now, phase 3 of the lesson is actually where the fun comes into play. Because if I then ask, well, what's the square root of, say, 13? Well, it becomes a bit more of a challenge, doesn't it? Because we know that 13 is not a perfect square. And then we have to use this model in order to help us to figure out what the square root of 13 is, or to be able to estimate it. And I'll show you how to do that. It starts off by making squares. So we start off with the first square, that is a 1 by 1. And then I keep going. So I go 2, 3, 4. And each time I do this, I keep making a backwards L. Then I'll go 5, 6, 7, 8, 9. I've made my third square. I'm going to keep going until I get to my 13th dot. 10, 11, 12, 13. Now, as you can see, this isn't quite a square, is it? But we can see that I'm somewhere between making my third square and making my fourth square. So I know that my answer is going to be between 3 and 4. So 13, the square root of 13, is somewhere between 3 and 4. Now, if I have a look at this, my third square is here, and my fourth square is here. Now, I've just finished my third square when I get to here, and I've started here, so I go 13. So 10, 11, 12, 13. I'm kind of halfway going from here around to finishing my fourth square. So I reckon the square root of 13 will be roughly in between 3 and 4, maybe halfway. So, for example, maybe 3.56, maybe. That's a guess, 3.56. And remember, we're estimating, so we don't have to get it spot on. But let's have a look. Now, what I like to do at this phase is actually just use Siri to help us out because it kind of adds to the suspense. So let me show you. What is the square root of 13?
The square root of 13 is approximately 3.60555.
3.660555. 3.60555. Well, wait a second. I said 3.56. So I was only 4 100ths off this answer. And when you think about estimating a square root and just how close that actually is, it's really close. Let me do one more example just to show you once again how the model works. I'll rub it all out and then I'll get back to you. Alright, so let's now have a look at, say, the square root of 18. Let's see what we get here. Once again, it's really important that we set out this model correctly. That is, we start off in the top corner and we keep building around. So there's 1, 2, 3, 4. I've built my next square. 5, 6, 7, 8, 9. I've made another square. So you can see here, I start here, I go around, and I keep making that square using backwards L's. If students don't understand this, they won't actually make the squares, and therefore they'll struggle with estimating the answer of square root of 18. So I'm up to 9. Let's have a look. 10, 11, 12, 13, 14, 15, 16, fourth square, 17, and 18. So now I know that I'm between my fourth square and my fifth square, because my two side lengths really are 4 and 5. So between my fourth and my fifth. So I know my answer will be somewhere between 4 and 5. Now all I need to do is try and figure out, well, where is it between 4 and 5? Well, I know here would be 5, and here is my fourth square when I finish off this one here. So I know I'm probably going to be closer to 4, aren't I? And here would be roughly halfway, because when I go around here, this would roughly be halfway there. So maybe 4.3, or 4 and 3/10. Let's see what we get. What is the square root of 18?
The square root of 18 is approximately 4.24264.
4.24264. Let's write that down. 4.24264. So once again, I'm only 6/100ths off getting the right answer, or roughly that. So you can see just how accurate this model can be when estimating square roots. That brings us on to phase 4 of the lesson. Now, phase 4, I don't always get to in every lesson, but for some students, it's really quite appropriate, because what I've found is, as we know, when we square root 18, we get approximately 4.24264. But of course, you guys being maths teachers will know that this is an irrational number, and the decimal places actually continue on forever. So therefore, when estimating a square root, you can never get an exact value unless you just leave it as the square root of 18 or write it as a surd. I don't go into that level with the students at this point in time, but we know that it's actually not possible to get it spot on the correct answer, because you're always estimating. That's how it works. But what students have done is they've recognized that, all right, well, I'm going to be between my fourth square and my fifth square, which is correct. That's what I've shown them. But what they've done is they've actually said, well, I'm actually 2 parts of 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm actually 2/9 of the way around. So that would be really 4 and 2/9. Now 4 and 2/9 becomes 4.22 repeated, essentially. Now we can see here that 4 and 2/9 isn't 4.24264. In fact, it's slightly off. And this can frustrate students at times, because they think that they're going to get it spot on, but in fact, it's not quite. And what that can lead on to is a discussion about the graph of course, y equals the square root of x. I don't go into great detail with this, but they can start to see that in fact, it's not linear in the terms of using fractions, but in fact, square roots actually have this shape of graph, and because of that, it's not possible to really use a fraction to help us out in terms of getting the right answer when estimating the square roots of any given number. And the other thing you can do is talk about how irrational numbers fit into the actual number system, that is, with integers, whole numbers, and rational numbers as well, and talk about other irrational numbers such as pi. So there you have it, a model on estimating the squares and square roots of different numbers. And what I've found is when students use this, they really start to develop in confidence and feel like they can do this for any given number. So I look forward to seeing how you use it in your classes. Best of luck.